DS18B20 digital thermometer and Arduino Uno with a 3.5-inch touchscreen LCD with two buttons that can switch between degrees Fahrenheit and degrees Celsius. I've done projects with this temperature sensor as well as with this touchscreen before. I'll link those below, but this project combines them both. I thought this would be a good project to get familiar with how to use the touchscreen buttons as well as how to do text on a touchscreen display and graphics. So right now at room temperature we have 25 degrees Celsius and we are at the 25 degree mark. So if I put the thermometer in cold water, so it's about 40 degrees Fahrenheit, 4.54 degrees Celsius, it's getting really close to zero. So this is set up so that whatever is being read out of the digital thermometer is going to show numerically at the top in the header. But this graphic, I was just playing around, so it's only set to go between 0 and 100, whether it's degrees Celsius or Fahrenheit, whatever mode I'm in. If the number that I'm reading is between 0 and 100, it will show on here. It's just meant to be a quick demo. My display is an MCUFriend display, so it's got all these parallel LCD control signals. And since the last time I used it, I somehow cracked the bottom right corner. It still works, although it does give some messed up calibration results we'll look at later, but it does work, so for now it's okay. With this screen, I also needed pins for the digital thermometer. So looking for spare pins, it looks like this bottom one here, digital 19 or analog 5 when it plugs in. This pin is not used. It routes over to, it looks like an unpopulated IC or connector footprint. So I gave it a shot and it worked. So I'm using digital 19 for the one-wire digital thermometer. And with the shield populated, since I can't get at the pins even if they're not being used, I soldered a 5-volt ground and then a signal wire on A5 or digital 19, so I can just run that out under the shield and it goes to this header I made, and I have the required 4.7K from data to 5 volts for the one-wire bus. So when the whole thing goes together, I can use this shield and a digital thermometer. So it just lines up at this bottom end, drops in, and there's the thermometer. And here's the simple schematic for that. Since I didn't have a symbol for this shield, I just took a picture of my actual unit and threw it in here. So this shield goes on here. The backmost pins on this shield line up with the backmost pins on this header. And as just pointed out, I have directly soldered wires for 5 volts, ground, and A5, which is digital 19 I'm using it as, to go to the digital thermometer, and I have an inline 4.7K pull-up from data to +5. And that's basically it. Then I'm powering it from the computer. Over on GitHub, I wrote some instructions on what needs to be done from scratch to get this screen up and running from MCUFriend. After the libraries are installed, the first thing we should do is run from the MCUFriend examples the sketch called Touchscreen Calibrator Native. So this will go through and figure out which is the plus and minus for the y-axis and plus and minus for the x-axis so that you can configure a sketch correctly, and when you touch the screen it'll show up in software at the coordinates you expect. And then it wants to calibrate what are the extreme edges of your screen, and it will auto-detect your X and Y analog readings for your resistive screen. And you also copy that over to use in a sketch. Here's the touchscreen calibrator native from examples MCUFriend KBV down at the bottom. So this calibration sketch is running. It's gone in and it's figured out X minus and X plus, Y plus, Y minus are analog 1, digital 7, analog 2, digital 6. And it says on this x-axis it read in 24, and up here it says you'll get about a reading of 25 or so if your X direction on your touch screen happens to be 300 ohms. So it looks like I've got a 300 ohm X direction touch screen, so I already know I'm going to use the value 300 for my X resistance. And these are the pins I'm going to use in my sketch, but we're not done yet. Probably hard to see, but over here it says touchscreen to continue. And now it's got a crosshair in all of these edges and corners. So you're supposed to press down on each crosshair and it will say to hold and release when it's done reading it. You just go all the way around, and as you're doing this, it's detecting where you're pressing, measuring the resistance, and therefore it knows what your screen edges are. So I've done all of those, and now it prints out some final info on the screen as well as the serial monitor. It's telling me I have this 320 by 480 screen, and here's the 2 lines that I can copy out to put in my sketch. So I'm going to copy that, and if I want, this is my actual thermometer sketch, so right here it's those 2 lines. I'm just going to go down here and temporarily paste in what I copied from the serial monitor. These numbers that I actually got right now and what I've been getting lately, like the left of the screen says 192, the right is 806, top 575, bottom 473. I don't know why it's doing this. I know this is not right, and I think it has something to do with the fact that I damaged the screen. When I used this for the first time earlier this year, these are the numbers I got. So these are the ones I'm still using, and they work. So I'm going to take that out and stick with what I know works. And that's all I need from this calibration sketch. So another thing I've learned, some displays might have inverted screen colors, and mine does. So, you try to say draw something black and it comes out white. If so, in the setup part of the sketch, you can add the line invert display true. So you would do that somewhere after you've initialized the screen. So I put this right after where I say to begin at the certain screen ID. And that's pretty much all I needed to do. Now I have that thermometer sketch running again. So the general graphic display here, the way there's this top header box with some stuff in it, and then this main box with the thermometer in it, I was influenced and inspired by an existing project. So I've put that as a reference in this sketch. That's a different type of thermometer. It doesn't use the digital thermometer I'm using. So I took the same basic structure. I basically rewrote the whole thing anyway, but it's based on what I learned over in that sketch. So we won't look at this in complete detail since it's a hybrid of previous projects, but we obviously include the correct libraries. Then we have the touchscreen calibration info from that calibration sketch. Then we create our display object. We're going to use MCUFriend to talk to the screen, and we're going to use the touchscreen library to talk to the touchscreen. So here's where we have the X plus and minus, Y plus and minus, and this 300 is the resistance on the X axis. So when I ran that calibration, based on what it said, a reading of 25 or so represents a resistance of 300 on X. I had 24. Sometimes I've seen 25, so I put 300 as well. If not, you can just measure the resistance. Whatever pins, my X plus and X minus are between Arduino pins digital 7 and analog 1. So I can just take a multimeter, and when the screen is not plugged in, I can just measure the resistance directly across these equivalent pins on the screen, and I can get the resistance and write it in here. Then in order to do different colors on the screen, it uses 16-bit color values, so it's got these hex color codes. So as a quick reference, these sketches tend to make some readable text names and associate the equivalent hex number. I added gray and dark gray. I found this blog that has this 16-bit color generator, so I can go over here and click on this hue saturation kind of graph and choose a color I want, and then it'll show me the hex values. So this was one of my gray colors I chose, and I copied and pasted this 16-bit color value over to the sketch and labeled it gray or dark gray. Then for the location of that thermometer graphic on the screen, here's some variables to say where I want the X and Y coordinates at the top center of my thermometer. This is where I am going to put it on the screen. And from there, I draw all the various aspects to build up a thermometer graphic. So I need to know the height of the thermometer, the width of the tube on the thermometer, and how big I want the radius on the circle bulb at the bottom of the thermometer. Then later, when I want to draw the red line showing the temperature, based on the temperature reading itself, I scale it within the height of the thermometer. Then I can use these coordinates and figure out where I need to draw red lines and fill in the background with white lines as the temperature changes. Then we need to set up the digital thermometer. So, as usual, I'm using digital pin 19 for the one-wire bus. Then I create the necessary objects, some miscellaneous variables here, the ID numbers of the screen, so that the MCUFriend library will go in and figure out what kind of screen it is, and then it can figure out how to talk to it. When we do have a touch on the screen detected, the X and Y pixel locations are stored here, and some variables for the temperature. In order to put the two touchscreen buttons, I use the Adafruit graphics library, and I've named two buttons degrees C and degrees Fahrenheit. Aside from initializing the digital thermometer as usual, I'm also changing its resolution to 9-bit. The default at PowerUp is 12-bit, so I'm choosing 9 bits, which gives me an increment of 0.5 degrees Celsius in my temperature readings. I don't need it to be as accurate as 0.0625 degree increments. And the reason I want 9-bit resolution is because it takes the least amount of time to go out and get a reading. It's under 1/10 of a second. Whereas if I kept it at 12-bit resolution, getting the most accurate temperature, it'll take 3/4 of a second. I know I need to invert my display because my colors are always backwards. I make sure I set my screen rotation for portrait, and then I clear the screen by filling it black. Here's the configuration of those two on-screen touch-sensitive buttons. So I'm setting for degrees Celsius and degrees Fahrenheit clickable buttons, what the text is going to be in the button, what the button colors are, and where they are located on the screen, how big they are, etc. Out in the main loop, we go in and read the digital sensor, so whatever format our temperature is in, we're going to store the number itself into a variable. Then we're going to go display that numerically up in the top header. Then we decide, do we need to update the thermometer graphic? Basically, if we got the exact same temperature, the red line is not going to move. So whatever our measured temperature number was, we assign it to a current temperature level by mapping it over between 0 and 100 degrees and 0 and the actual height of the line on the graphic of the thermometer. So if our temperature is 50, whether that's Celsius or Fahrenheit, doesn't matter, it's halfway in this range, so it should equate to a number that represents halfway up the thermometer physically on the screen. So if the temperature now is different from the last time we read it, go in and redraw the new red line and white line in the thermometer. Next, we want to see if any buttons on the screen were pressed, and this code is basically copied over from one of the demo sketches, button simple, in the MCUFriend library examples. So all this really does, check if a button's been pressed on the screen, and if so, depending if it's the button for degrees Celsius or Fahrenheit, change whether we are showing degrees Celsius or not. That's it for the main sketch. So then we have two routines here. This is what actually goes in and handles the screen presses. Again, it's from that button library example. It'll map the analog resistance voltage measurements over to the range between 0 and the width, or 0 and the height of the screen. The only other routine left is the one I used to draw the thermometer one time only in the setup part of the sketch. Since it's so messy, that's why I threw it out into its own routine. And this part was heavily influenced from that example sketch I showed at the beginning from this project here that I found. But I've basically rewritten it at this point. The thermometer is drawn in 3 different sections. One is a black outline, which represents the outer glass walls of the thermometer, and it's drawn as a solid shadow, basically. Then we fill it in with a smaller white inside pattern, and that represents the inside space of the thermometer that does not have any red liquid. Then finally we draw an even smaller red inside to show the actual temperature level. The thermometer is drawn in 2 different phases. First, there's a vertical tube, and I use a rounded rectangle, so the top is going to be rounded automatically, so it's not just a boxy top, it's rounded. And it will also round the bottom, but that's going to be hidden down here when it's overwritten by the red. So we draw the height of the tube as a rounded rectangle. Then down at the bottom, we use a circle to draw that big bulb at the base. It's possible there's bugs in here as well, but I did the best I could to make it accurate. I put all these tick marks on the side of the thermometer over here so I can show major thermometer increments and all the minor ticks. So here we have 24.5 degrees and it's between the 20 and 25 ticks, so it's pretty good. When I did not have these markings, it was really hard to tell because it was like an optical illusion. Something might have been perfectly centered, but it looked like it was more skewed toward the top, things like that. And then I want to put actual number markings beside the major tick marks, 100 degrees, 75, 50, 25, 0. This is how we can use the graphic library for the touchscreen to do various shapes and make drawings, or set up colors and do some text at different sizes. Printing out to the TFT, this character 247 prints the degree symbol. So that's how we can get up and running using a touch screen and make some clickable buttons, do graphics, do text, interface with sensors, and how to make it all work together on an Uno.